Hello and welcome to this video. In today's video, we'll be discussing how one can be able to move from zero to hero in machine learning. That is how you can be able to quickly become a machine learning developer even if you do not know anything. Therefore, this video is suitable for upcoming developers, those who are starting from scratch, and also developers who are at the mid-level and would like to know more about machine learning development. So to start with, you need to have a programming language. And the most popular programming language in machine learning and artificial intelligence in general is Python programming. Now, in Python, you don't have to focus on nursery things such as Django platform for web development. Rather, you focus on specific libraries that are used for machine learning development. These are NumPy, which is used for dealing with arrays. It helps in converting your data from a CSV file into an array, both a single dimensional and a multi-dimensional array, depending with how your data looks like. Pandas, which enables you to load your data. It also enables you to interact with your data, such as determining association rules in your data. We have Matplotlib and Seaborn, which basically perform all the plotting functions and all the visualization functions that you may need in your machine learning model. This could include visualizing your data, visualizing your results, and so on. On top of that, you need to learn some basic concepts of classes and objects in Python, because Python is object-oriented. Because at some point, you may need to do some inheritance, or you may need to do some abstraction, you may need to do some polymorphism, and so on. You also need to understand a bit of data structures, and these include how data structure algorithms such as stacking algorithm works, how piling algorithm works, and so on. Now, what IDEs can one be able to use in order to learn Python easily or to program in Python? You can download the Anaconda distribution environment. Once you download it, it comes with a number of components in it, and one of the components that it comes with is what we call the Jupyter Notebook, which is the most preferred editor by many professional developers. However, there are also other editors that exist, such as Spider, and they will come together with Anaconda. Others still use Visual Studio Code, and it will still be there in Anaconda, and so on. However, Jupyter is the most preferred. Anaconda is suitable, especially if you have a machine with a good random access memory of about 4 GBs, because it usually takes a lot of memory space, especially when it is running. However, I would discourage you from using Anaconda if your machine is not powerful enough, or if you are creating models that are heavy and required to run for a longer period of time. So where one cannot be able to use Anaconda, what else can you use? You can use Google Colab. Google Colab was developed by Google. It is a cloud-based software, a platform as a service, which makes it possible for you to go there, program, create your models, train your models, evaluate your models, get the results, and so on, all happening on the cloud. Google Colab is free. However, you can be able to subscribe to premium versions. We have what is known as Google Colab Pro. Currently, it is charging $1.99 US. You can also subscribe to Google Colab Pro Plus to get more GPU time, and that one is something that will even enable you to perform parallel processing. After doing a programming language, now the machine learning pipeline involves a lot of data, and you really need to know where you are going to get your data from. So at point number 2, we are going to discuss data acquisition, and there are two main sources of data. We have what we call the primary data and the secondary data. Primary data, you collect it yourself, and then you annotate the data. Here you can collect it depending on the task that you want to do. You specify the kind of data that you want, and when you are collecting this data, it is important to make sure that you do not introduce a lot of noise to the data. It is especially important for you to collect your primary data if the area that you are working on doesn't have any existing secondary data, or you would like to contextualize your model to specific contexts. If in your area there is secondary data, or perhaps you do not have the resources to collect primary data, then you can use secondary data. Secondary data is usually available in repositories. The most popular repositories today are Kaggle repository, which hosts a lot of data. Kaggle will also provide you with some existing codes or some existing models that have been trained by others, and you can be able to learn a lot from them. You can also check some data from GitHub. However, in this case, Kaggle carries the day because it has almost all sorts of data. If you cannot find it in Kaggle, it probably doesn't exist. After doing data acquisition, you also need to understand some frameworks that are mainly used in machine learning. And some of the major frameworks that you need to learn are TensorFlow. TensorFlow was developed by Google, and up to date is still maintained by Google. It is the most used framework, especially for those who are going a step further and doing deep learning, especially if you want to do issues to do with image processing. TensorFlow is especially very powerful. It has Keras in its backend, which contains libraries which have also very powerful third-party support, and they make it possible for you to code with less code. Therefore, it reduces the amount of lines of code that you need to write in order to perform a specific function. You can also be able to use PyTorch. PyTorch is by Facebook, currently known as Meta. PyTorch also has the same capabilities as TensorFlow, but in terms of market share, TensorFlow has a larger market share. There are some developers who prefer to learn both, but for beginners, I would advise that you start with one of them. In this case, I would advocate for TensorFlow, especially if you want to get a career immediately after learning these basics of machine learning. After that, you can also check OpenCV. OpenCV is mainly used for image processing, and OpenCV is also powerful. However, its capabilities cannot match those of TensorFlow and PyTorch. Scikit-learn is also another framework. However, scikit-learn is not suitable for artificial neural networks or what we could call deep learning models. It is only suitable for basic machine learning models. And you'll find that if you are just developing a model, maybe to predict wine quality, you're just developing a model, classify something as a true or false, scikit-learn is a very light library for you, and you'll be able to access it easily. After knowing the frameworks, you need to know how exactly you're going to evaluate the performance of your model. So number 4, we talk about evaluation metrics, and we have several evaluation metrics that exist. These include accuracy, and this one basically deals with the rate at which your model is able to accurately classify the data. And we have others such as precision, recall, F1 score. We have also the receiver operating curve and the area under the curve. However, it is important for you to know that the evaluation metric that you choose purely depends with the type of task that you are doing and the aspects that you want to measure in your model. For example, somebody who might be interested in measuring how well their model is able to differentiate between two classes, then the area under the curve would be most ideal. One who might be interested in knowing how well their model is able to balance between precision and recall and F1 score would be desirable for them. So thank you guys for watching this video. Please consider subscribing, liking, and sharing the video with your friends so that they can also benefit. Thank you.